Hi everybody, it's Derek from Spark Fun Education. Today we're going to explore the gator bit and our gator simple circuits kit using the basic gator boards. We're going to go over what's in the kit, what a simple circuit is in terms of a parallel and series circuit, as well as build a really simple cloud storm diorama that maybe your 4th or 5th grade student can complete in a class period or two. So with that, let's jump in.
Okay, now that we have the introduction out of the way, let's take a look at the kit itself. It's made up of a couple different PCBs and some other components. We'll go over them one by one. First of all, it includes the gator bit itself. And then it includes 3 sets of gator boards. First up is the gator control. It includes 2 push buttons, an on and off switch, as well as a reed switch. If you've never used a reed switch before, it's similar to any other switch, but it's triggered by a magnet. So if I place a magnet on top of it, it's like pushing down on a button. If I pull that magnet off or remove it, it's like letting up on the button. So it's a really fun switch to play around with. Next is the gator starter. This includes 2 analog sensors, a temperature and a light sensor, and an RGB or red, green, blue LED. Last but not least is our gator color. And I've already broken this one out from before, but it includes 2 white LEDs, a red, a yellow, a green, and a blue, as well as a power strip for breaking out more power as well as ground pins. Alligator clips, tried and true way of hooking things up, and a battery pack. So now that we're introduced to everything, let's take a look at how to kind of snap these things apart and start working with them. First of all, as you can see, I've snapped some of the LEDs apart already, but what I want to do is kind of show you some tips and tricks on how to safely snap some of these things apart, because it is a little tricky, especially for little hands. And I actually highly recommend, if you're going to be doing this in the classroom, that you do this ahead of time if you're working with younger students. So taking the gator control, we can see that there is some connections here, we call them mouse bites, in the PCB. And it's designed that all I have to do is just give it kind of a twist, and they should pop out pretty easily. Again, with the switch, just do that, pops out pretty easily, and the reed switch as well. What's left is scrap PCB. You can throw this away, take it to any e-recycler you have around, or incorporate it into a project or something like that as a piece of scrap material. The gator starter set's a little trickier. They're bigger PCBs, and they tend to have, instead of just 2 mouse bite connections, there's 3 or 4. And so they are a little trickier, and what you want to do is kind of bend and work with this. I like to use some needle nose pliers to just grab part of the PCB and snap it. A couple of the mouse bites, and then they should come free. Again, I'll take the needle nose pliers, and I hold on to the frame and just bend, and you'll hear it snap. I usually, if you get 2 of them free, it'll come loose pretty quickly. Again, snap them off, and you'll get some of these traces will pull up. These little, it's actually copper wire if you look at it up close, and these can be removed with pliers again. But one of the things is that it'll leave this sharp edge on a lot of the gator boards, and that's one of the things I recommend using a file, and just file off some of those sharp edges before student use, especially younger student use. Nice and flat, and it'll just take a couple of minutes. Now I have some nice flat edges on that gator board. LEDs, again, I'll pick this one up and show again demonstration, just a file. You can lay this flat and actually have students do it flat as well. I like to just hold it, and you can see there it's taken off what's left of that mouse bite pretty easily. So a little bit of prep work done. Now to hook these up, so now that I've broken all these out, to hook them up, you use alligator clips. Alligator clips are used for prototyping and building up test circuits a lot of the time. They've become a very popular way to hook things up for younger students in the maker culture and maker projects, because it allows them to hook up things without using a breadboard. And you just open the alligator clip by pressing down on the two back parts of it, and I'll actually pull this back so you can see what it looks like behind the plastic shroud. And so we just press down, and that opens up the alligator jaws, and then we can hook that up to the LED, and we can come from behind. You can go straight down or from the side. And what those do is that they'll connect via these pads and build a pretty solid connection. Another option for these, instead of alligator clips, are banana clips. And they look like this. And they hook up via just the holes in the gator boards. And they just get inserted and pressed down. And that gives a good solid connection for hands that it may be difficult for you to open and close the alligator clips. They are a little higher profile in terms of you get this big kind of connector in the way. So a lot of times I recommend connecting it from the back, especially for LEDs, so that the LED can light up from the front, and then all the bigger connector stuff's on the back. So that's two different ways to hook up our gator boards. The gator bit itself, we've covered it a couple of times already, but it has a power strip, your pins, so it has pin 0, pin 1, 2, 3, or sorry, pin 8, pin 16, pin 5, and pin 11. Pin 5 and pin 11 are the same pins that are on the microbit A and B buttons. So anything you hook up to 5 and 11 would be treated just like you were pressing the A and B button on the microbit. On the left-hand side are more pins there for advanced sensors. Our Gator Science boards are the ones that hook up on this side of things. So we're going to be using primarily these pins down here, as well as our power strip. To insert the microbit, we want it screen up, buttons up, and we just insert it that way. And now we're ready to start building some circuits and build a project. Okay, so before we jump into our project, one of the things that I want to talk about a little bit are just basic circuits. You know, what is a circuit? How does it work? And how do we use the Gator bit to teach basic circuitry? And we can do that actually without the microbit. So I'm going to take this microbit and I'm going to set it aside for now. And we're just going to focus on using the Gator bit and this battery pack. So I'm actually going to plug the Gator bit in, again, without the microbit, and some LEDs will turn on. Notice that the 3.3 volt out and the 5 volt out turn on, as well as our general indicator LED. So we have this powered, and what we can do is we can use this as a tool to build basic circuits. The first circuit we build is actually what not to do circuit. It is a short circuit, and what a short circuit is that power and ground end up getting connected without any of the current or electricity doing any work for us. That's bad. And what we can demonstrate that really quickly with a single alligator clip jumper wire, connecting that to power. I'm going to connect it to 5 volts for now. And then if I connect it directly to ground, you'll notice that something happens. So if I just touch ground, the LEDs turn off. What that is the gator bit itself actually protecting itself. So there's some specific circuitry in here to protect itself from being damaged by short circuits. But we can use that to our advantage and demonstrate a short circuit. If you're working with your students and that happens, where things are plugged in, everything's turned on, and the LEDs turn off, that's telling you that you have a short circuit somewhere, and then you need to do some debugging. We want electricity to do work for us. And so we're going to demonstrate, or I'm going to demonstrate, some really basic circuits using the gator bit and some of the gator boards to just demonstrate the idea of both a parallel and series circuit. Okay, the first circuit we're going to build is just a simple circuit. We're going to have an LED light up. And so I'm going to grab an LED. Let's see here. We'll grab the red one. And on the LED, it's hard to see. And I'll bring it closer. You can see that there's a plus and a minus. So the plus is going to go towards the power jumper wire we're going to use. The minus is going to go towards ground. So I'm going to use a red alligator clip for power, and black is going to be my ground. We're going to use, for this example, I'm going to use the 5 volts out. Normally in microbit applications, you'd probably be using the 3.3 volt out, but for building these basic circuits without the microbit, I'm going to be using 5 volts. So I'm going to hook this up to 5 volt, 5V out, and then the other end is going to get connected to the plus side of the red LED. Notice it doesn't light up yet. I have not completed the circuit. If I follow this wire, it does not make its way to ground at any point. But once I add a ground wire and hook it up to ground, the LED lights up. I have a complete circuit or circle. It passes through the LED, goes through the wire to ground. Current and this electricity is now doing work for us. It's lighting up this LED. Not many projects out there will always have an LED on or off. Usually there's some way to control it. I'm going to actually incorporate a quick button into this project so that I can control when that LED is on or off. So I'm actually going to disconnect it from the LED at this point, and I'm going to insert a button in between the power source and the LED itself. So I'm actually going to hook up power to this button, and then I'm going to add another jumper wire that goes from this button now to the LED. So is this a complete circuit? Yes, I can follow from the power source through the button, through the second wire, through the LED to ground. Why isn't the LED lighting up? Because I haven't pressed the button. I have to press that button to complete this circuit and let electricity and current flow through it. So let's see what happens. And it does. When I press and hold it, it stays on. When I let go, it turns off. This is a series circuit. All of the components are in one line, a single file line basically, between the power source and ground. So if I follow that line, all of them, it goes through one to get to the other. Be able to turn it on and off with the button. I can even add a second LED. So I'm actually going to break the circuit, and I'm going to add a green LED. Again, make sure that your plus on your LED is going towards the power side. So I'm going to add this right here, and I need to add another jumper wire in here, and I'm going to use, let's say a green LED. I mean a green alligator clip, because it's a green LED. And that's going to connect from the negative to the positive of the red LED. And now, if I press this, both LEDs light up. They're in series. Follow that line from power, should go through all of the components to ground. So that is a series circuit. They're all in a single file line, and power flows through all of them, or current flows through all of them. Okay, we're now going to move from a series circuit to a parallel circuit. And if you're thinking about the holiday season, you all use parallel circuits if you put up Christmas lights. So old Christmas lights used to work like this series where all the lights or the bulbs were in one row along one wire. And when one would burn out, everything past it would not work. The Christmas lights have changed since then and now are in what's called a parallel circuit. And it's really hard to demonstrate that in the wire. I'm actually going to draw a diagram first, and then we'll actually modify this circuit to become a parallel circuit. It'll actually be a combination of a series and parallel. So I'm going to move this out of the way really quickly, and then I'm going to grab a pen. So if I have power source, let's see, that's plus, and here's ground, power and ground. We know that if I current, and let's say that this is an LED. That's not the proper drawing for an LED, but I wanted to give you the idea and not use technical icons. And then back to that. So that is technically a series circuit. Right? It goes from one, passes through the component, and goes back to ground. A parallel circuit takes this and just kind of adds on. It remodels the circuit so I can actually do this. And ground attaches there. And I can keep adding those components. So there's three LEDs or three lights in parallel. If I was to follow the current, it goes through here to ground. It can go also through here to ground and go through here to ground. If I remove one of these LEDs, what happens? If I remove this or it burns out, these two still have a complete circuit. Current can pass through that LED to light it up and return to ground. This as well, pass through, return to ground. So that the circuit's not interrupted if I remove or change things inside of this parallel circuit. We can use that to our advantage if we wanted one LED to be on all the time and then control other things off the same power source. So let's take a look at that. If I, let's say, have this LED that I want on all the time, and I want to control these two LEDs separate from this first LED, I can actually put a button or a switch right here. So I'm going to do that. I'm going to actually make a quick modification. Use blue, and I'm going to put a button right here, and this is actually the icon for a button, so let's make sure it looks like it's separated. So now this LED will always be on, but these two will not light up until I push down on that button. So current, again, if I follow this will always be on unless it burns out or is removed. But these two will only light up when I press that button. And I complete that circuit. These two turn on. This will also stay on as well. So it's a way to isolate one part of the circuit while doing something else with the current as well. So this button, these could be motors, these could be other things, but it's just the idea that these I can actually separate out and use this power source for different circuits while leaving something on, controlling other things, well, if they're in parallel and not in series. Let's bring the gator bit back and some of the components and see how that works in wiring. Move this stuff out of the way, make sure it's nice and clean. I'm gonna, instead of 2 LEDs over here with the button, I'm gonna try to keep it as simple as possible and stick with the 2 LEDs I have. One of them is going to be this LED, where it'll be constantly on, and this LED will be controlled with the button. So it'll be essentially, if we had looking at our drawing, it will be like this. And I'll actually, so we're building that circuit there. So first off, let's get this LED here built. So it's just like our original circuit. I'm actually going to take, and that's lit up. And there's a button here. And my LED, my second LED, my green one, is going to go right there. So what I need to do is be able to jump now from here to the button, from the button to this LED, and then from the LED back to ground. I can do that with the alligator clips pretty easily. I can actually uncover the clips themselves and use them to clip other alligator clips too. So now I can take another alligator clip, clip it there, clip this to the button, clip this to the button there, to the LED, and one last alligator clip back to ground. Make sure this is on there nice and tight. Okay, I know it's kind of a mess of wires, but it emulates this drawing underneath. So I have power to this side of the LED that then is also connected to the button, which underneath the drawing you can see is right there, that then passes through this LED, which is not on yet, and then to ground, and this ultimately goes to ground on the gator bit. So if I push this button, this LED can be controlled on and off with the button, and this LED stays on all the time because there's no button interrupting that part of the circuit. So this is a really good illustration of a parallel circuit, and we can actually add a bunch of other things to this side of the circuit. We could have a button here, or an LED here, but then we can add, let's say, a switch and another LED. So we can have a button that controls this LED, but if I want to use another LED and let's say a switch, this switch has to also be on and the button pressed. So you can add some technicality and start playing around with the idea of two things, and, or, so again, some binary logic ideas. With this in mind, let's go build a project. Our project, I was thinking about it and I was like, what are we going to build that's pretty simple, that uses simple circuits and the components in our kit, that could be used in a different classroom or just in any class really. And I was thinking about science, and I was talking to my son who's a 4th grader, and they were exploring and learning about different types of clouds and weather associated with them. And so I wanted to make a really quick diorama of a cloud, a storm cloud, that's a lightning, it's producing lightning. We'll use the microbit and the gator bit and some of the gator boards to make that lightning flash in the diorama. So I have some cloud here, which is just some pillow batting, a bit of yellow wire to use as a lightning bolt, and I'll bend that up. You can use a pipe cleaner as well. You probably have more of that in your classroom than yellow wire. In terms of the electrical components, we'll obviously be using the gator bit. We'll add the microbit to it, a battery pack, a white LED, and we'll use a button as well. So those are the components, oh yeah, and a bunch of jumper wires. In terms of other tools to use, if you have all your gator boards already snapped out and ready to go, I'm going to be using a hot glue gun, but you can use, depending on how permanent you want to make it or non-permanent, You can use clear tape to tape things down, but I'm going to use hot glue so that it just sticks down. Hot glue is really nice to use because you can actually peel it off the back of PCB pretty easily, and it's a nice permanent attachment or semi-permanent attachment when the project's finished. And then when they're all done, everything's graded, we're good to go, we can actually peel things off the project pretty easily. So with that, let's get started. I started out with this box. It's actually a SparkFun box. I already lined it with some blue paper to kind of simulate the sky. I tried this with black paper and it didn't look great, so I tried to find a darker blue. Again, line the inside of it really quickly, and I punched a hole so that I can pass wires through and place the LED inside. So the first things first is I am going to get the LED placed in here, and then I'm going to add kind of the cloud behind it and make sure that gets where it's supposed to be. So I've done this a couple of different ways where I put the LED first and then I alligator clip to it, and in terms of hot gluing it. I actually like the idea of making sure everything's hooked together and then hot gluing it down. So I'm going to grab my white LED and I'm going to add a red and black jumper wire to it to start with. So red being the positive side of the LED. And again, I'm going to move this sheeting of the alligator clip really off, almost completely off of the alligator clip, so that I have free control over it and I can attach it. So I'm going to attach it like that. And black, that one seemed to go on just fine, so I'm going to leave it. And then the other ends of the wires, I'm actually going to pass through this hole in the cardboard box. And then figure out where exactly I want to place my LED. Get the wires situated here. Kind of somewhere in the center of the box I think would be good. And I'm going to just take a little blob of hot glue. Put some hot glue there. Try not to get hot glue strings everywhere. And just place the LED on top of that hot glue. Again, you could have done this before pretty easily and then just alligator clip to it. I like to kind of make sure everything's hooked up beforehand. One of the things that does cause, though, is that the alligator clips hold the PCB off of the project a little bit. With the battery pack installed, I'm just going to test the LED to make sure everything works. So I'm going to hook this up to my 3.3 volt out as my power supply and ground. And what I'm doing, why I'm doing this, is because I want to also be testing what this looks like behind my cloud. Right, so if I get the cloud down there, I got to make sure it looks like the right type of cloud, big, tall, billowy cloud. And it's hard to see with the light, but if I cover up my spotlight here, you can see that the LED really illuminates. You get it kind of how you want it, and then again you can take some hot glue and just put a couple of spots so it holds the cloud in place. Put that there. Now, this is a quick project, I know. So these wires could come from the back of the box, could come from the top. You could build something that, or add more paper to cover them up. But for now, I wanted to illustrate a quick project. So if you were going to refine this a little bit more, I'd probably have the wires come in from the back of the box. To build my lightning bolts, I'm going to use some wire and my needle nose pliers. I'm going to add some jagged bends in this to make it look more like a kind of a cartoon lightning bolt here. And I can just add that in there. Again, Really quick example project. Not looking for the winner of my Maker Faire project or something like that. Add another lightning bolt. I can add that in there. And you can glue those down if you'd like. For the sake of time, I'm just going to kind of let them sit in there. Okay, lightning cloud. Now, everything's tested. I'm going to move this up so we can see how we're going to build this circuit. What we're going to do, and I'm going to unplug the battery, is that I'm now going to, now that I know that it lights up properly, is that I'm going to modify this circuitry a little bit. I'm going to leave ground where it is because this LED needs to be grounded. But I'm going to move, instead of the 3.3 volts, I'm going to move this to pin 1, or P1. So I'm going to move that right there. So that is going to be controlled by pin 1. So instead of a constant current from the power source, I will actually end up programming the microbit to turn this on and off. I'm going to add the microbit now to the gator bit. Nice snap into place. And now we need to add the button. So the button is going to be connected to pin A and ground. So instead of what's the microbit's going to do is it's going to look at pin 5 or the button A, and if that has voltage on it, so it's high, it's in that normal state. If I connect it to ground, I'm pulling that pin low, or I'm grounding that pin. And the microbit can look at that and go, that button's being pressed or not. So I'm going to grab some jumper wires, and you can do this too if you want to do a kind of an intermediary project with this. You can just use this button here, the A button on the microbit, without having to add this button right away. And in fact, that might be a really good step for us, actually. What I'm going to do, I'm going to make a middle of the road change here, and we're going to actually put this aside, and we're going to program the microbit first and test it with this A button here, and then we'll add external hardware after that. So let's jump into programming and go from there.
Okay, so I've opened up make code for microbit. You can see the link here, makecode.microbit.org. And we're going to program our storm cloud project. So we're going to do some basic things to get it up and running, and then go over and see what it looks like in the project. So first things first, we're going to have an LED, and our LED is not one of the LEDs that you see here on our microbit. It's connected to a pin on our microbit itself. And so we actually have to use the advanced blocks under pins. And what we're going to be doing is we're going to be digitally writing to this pin. Digital write means you're turning a pin on or off. So making it either a power source or 3.3 volts or ground off. So we're going to digital write, and instead of pin 0, we're going to do pin 1. And so this programming block shows us we can either have it 0 as off or 1 as on. And I can switch it back and forth here, or I can just type 1 or 0 there. But we want to have this turn on and off when I press a button, and when I press button A. And we can find the event block for button A underneath the input drawer. And I can grab the on button A pressed. What do we want to have happen? Well, I want the LED to flash a bunch of times like lightning. And so I'm going to build a flash sequence, and I'm going to do that using a quick repeat loop. Because I don't want to put a bunch of blocks one right after the other. It'd be like 8 digital write blocks. I want to be able to create a flash and then tell the microbit to repeat that over and over again. So I'm going to say repeat 4 times, and I'm going to digitally write or turn on pin 1 on, And then I want it to wait a little bit. I'm going to use a pause block. And I want it 100 milliseconds sounds about right. And then what I'm going to do is add another digital write to pin 1 to off. And then again, another wait or pause. So this is going to, when I press the A button, it's going to repeat whatever's inside of this, and it's just going to blink 4 times. Turn on and off 4 times really quickly. And that is our program for this very, very basic thing. When I press this A button, it's going to turn or blink pin 1 on and off 4 times rapidly, and then wait for me to press the A button again. We can actually test that in the simulator. If I go over here and I press the A button in the simulator, you'll see pin 1 turn on and off here really quickly. And that's actually a pretty good, like I would say, animation for a lightning strike. On and off, super fast. One of the things that we can do, if that seems too fast for you, is that we can actually duplicate this again and put a longer wait between the 2 repeats. So I'm actually going to take this pause, and I want, let's say, 100 milliseconds. So I want 1 second or 1,000 milliseconds between these 2 flashes, sets of flashes. So it's going to lightning strike, flash, 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 wait a second, and then flash, flash, flash again. So let's try that in the simulator and make sure that works. Perfect. Again, our LED will be connected to this pin, so it'll blink like that. So I'm going to zoom out so you can see the whole program. Again, there's nothing in, I'm going to find my on start and forever. There's nothing in either one of these blue on start or forever blocks. It's all inside of my on button pressed, button A pressed. So I have 2 repeats, 2 repeat loops, both of them with blinking or flashing pin 1 rapidly 4 times each. So let's see what this looks like once I get the code into the microbit. First thing I'm going to do is make sure that I download the code to my microbit and then can go test it later. So I'm going to download it now, and it'll go to my downloads folder. And then what I'll do is I'm going to plug in my microbit into my computer. So it downloaded as microbit untitled.hex.
Okay, I've downloaded the program to my microbit. I have everything hooked up just the way I did before. Now to test it with the built-in A button on the microbit. So I'm going to press this A button, and then we should see my lightning flashes happen here in the cloud. Oh, there's 1 lightning strike and another. Again, I can press this A button again, and what it's doing is turning pin 1 on and off rapidly, turning that LED on and off. Now, the next step of adding that external button, if we wanted external control rather than using the button on the microbit, we can do that. And so we're going to need a button and 2 jumper wires. I'm going to have a black ground alligator clip, and I'm going to use a green one as well. So the black, I'm going to connect to ground. So again, like I said before, the microbit is looking at pin 5 or pin 5A down here, and a button press or a completed circuit to ground, me pulling that pin to ground, is the same thing as pressing this button. So what we want to do is have this button control current flow to this ground pin here. So I have it attached to ground on one end, and I'm going to add this green alligator clip to, again, pin 5 down here, the A button. Now if everything's wired correctly and I press this button, it should act just like it did when I pressed that A button. And I'm going to press it now, and it does. So I get the double flash, I get my lightning strike. Pretty cool. Again, very simple setup. If I was a teacher, I would be looking for a little bit more intricacy from my students, but this is something that they could probably build in a class period, or maybe a class period and a half if they wanted to add a couple bells and whistles to it. You can using some pillow bat, some wire or pipe cleaner, and the parts that come in our basic circuit kit to illustrate a lightning strike or a lightning storm. So again, I hope this video series has been helpful for you around thinking about incorporating the Gator Simple Circuits kit into your classroom, and the Gator bit specifically with the microbit. Hope it gives you enough confidence to maybe try it out with some of your students. Please share your projects with us. Again, share it with us via email, Twitter, any way you want to. We're always excited to see them and share them out with the rest of our customers and other teachers. So thank you again so much for watching this video, and check out episode 3 about using the Gator science sensors to do some data logging.